My name is Shawn. I am an infinite learner, and I like cephalopods. And cephalopods are this class of creatures which are, I don't know, well, octopuses are one of them. Although I love the cuttlefish. We don't have cuttlefish emojis until end of 2018. But I'm here to talk about React Suspense. You've heard a lot about it. You may or may not have seen Danny Romov's talk. That is highly encouraged, even though it's not required for this talk. It would help your understanding a lot, and this is meant to complement that. And I'm just going to get started. Oh, and also the slides will be available on Spectrum.chat, which is the new sort of chat platform. First of all, a disclaimer, I am absolutely not qualified to talk about this. In fact, I am so unqualified, I run a podcast called Imposter Syndrome. Some of my panelists are right down there, fellow alumni from Full Stack Academy. Literally, this is, I don't speak on the behalf of React team. And this is just what I've researched after spending dozens of hours on this, because I think it's very interesting. Also, don't use this in production. So I just, disclaimers out of the way. All right, we're all good? We're all adults? Good. First of all, I want to start off with, what does React let you do without thinking? So there's this quote about what technology enables for you. And I really like this idea of technology should just give you a tight abstraction that you don't have to ever think about again. So it just goes like this: civilization advances by extending the number of important operations which we can perform without thinking about them. And what does React do for us? So why do we like React? Why do we like any framework over Vanilla.js, which, as we all know, is the fastest framework? Vanilla.js is hard to reason about. If you have ever done the same exact app in Vanilla.js and React.js, in fact, just go do it right now. Even if you know React, just observe the differences in terms of, I've got a whole bunch of event listeners here. I've got to set up and remove the event listeners manually. It's a pain. In React, everything's organized more or less by force. You have escape hatches to do things with. But by and large, your components are going to be organized in a very standard state handlers and render way with lifecycle methods and stuff. So that's what React does for you, and it helps you, it guides you towards best practices, and that's the frame of mind I want you to think about when you come to think about async rendering. That's the larger context behind what React Suspense is, so I have to spend a few slides on it. Async rendering is a new feature of React that's coming this year. It's a bundle of two different features, time slicing and suspense. And we're going to talk about suspense today. This is the React team's official definition of async rendering. It's adaptive to fast interactions as well as slow interactions, which doesn't so a lot of this talk is just going to be me trying to find different ways to explain this to people. I've explained this, I've given this talk about 3 times now, and I think the best way to learn is just to, if you don't understand it the first time, just find a few different ways to explain it, and maybe one of them will actually click with you. So let's try what is async rendering again. First of all, I'm going to start off with the history, right? This is 2014. That's Jordan Walk down in there, and that's a random user of React asking him, hey, when is async rendering coming? What's the ETA on that? LOL, it's 4 years. But that's it's not something that just showed up overnight. This is something that people have been working on. In fact, since the React Fiber rewrite, which started in 2016 and finished in September 2017, that's the whole process of rewriting React just to enable this thing going on. Started talking about it publicly in March 2017. The React Suspense API came up with it in December 2017, and that brings us to the present day, which is what happened this month with Dan Abramov's 2 talks. A lot of people only watched the first one. He didn't have time to present all the features of React Suspense, so I encourage you to watch the second talk as well. So what is React Suspense? It is a generic way for components to suspend rendering while they load. So those 2 elements, again, very, very concise, but really, what is it? So let's try again. It's a fundamentally new capability. Lets you render a component tree in the background, while components are fetching data, and then display them only after. And it's very important, only after the whole tree is ready. It gives you full control if you have slow connections, and it doesn't destroy the previous view. Read that as it stays interactive while you're loading stuff in the background. So who made React Suspense? This is the entire React team. Daniel Baroff didn't do it alone. He's the front man. When can I have it? By the end of 2018. Don't ask for it earlier than that. And so those are all the basic questions. I'm just blasting through the things that everyone should know, right? I don't like it. I don't have time to learn it. Do I have to use it? No, it is 100% opt-in. If you want to load your data the old-fashioned way, go ahead. But this is cool, and it might make your life easier, so that's why we're here. All right, cool. And this is so this is the React Suspense cheat sheet. I don't have it right now. I'm gonna go get it. So just hold on here. I'm just gonna go get it. So I'm gonna switch over to my work in progress slides. Yeah. Okay. So now you start to see things fraying apart. Like I don't have my octopus anymore, and I'm a little like So octopus slides are good slides. Poop slides are not so good. And because I'm trying to show you the cheat sheet, and I don't have my data. I'm trying to load my data. So this entire room, we're gonna go and fetch that data and then load it onto our component, load it onto our page. So we have a full cheat sheet, and that will be our goal. I hope you're with me. So first of all, we're going to dive into code. We've got three different sections here. We've got benefits, use cases, sorry, goals, the big ideas, and code, right? So we're going to start with code. The first thing that we're going to start with is the two new primitives that we're getting in React, is React.timeout and React.async mode. Then we're going to go one level up from React primitives to low-level APIs. These are technically done in userland, but the React team has written a sample implementation of caching, and then they call it Simple Cache Provider, and the community is going to be expected to write more, including Apollo and Relay, and potentially you guys, because caching is a very complicated subject. Obviously, it's one of the two hard problems. You're going to find different use cases for your different needs. Just to walk you through what is required in the low-level API, this is how you create a cache. And the type signature of the cache is really that simple. Really, the whole source code of this is 300 lines. You can do it. But you just create a cache, and the most controversial bit, I guess, of React Suspense and why it's called Suspense at all is that you throw promises when you run into things that you don't have cache already. Like you're trying to pull data, and you go to the cache and you say, do you have this data? You don't. So your cache throws suspenders, which are actually just functions that return a promise. Suspenders, which are promises. That's you're essentially abusing the fact that throws go back up the call stack, and even though your function has not actually errored, you're throwing an error. Does that make sense? No, good. So, so that's the crazy bit. You might also hear about this as termed as algebraic effects. The better way to think about this is resumable exceptions. I have a whole bunch of links. My slides are full of links. They all have their homework for you guys if you want to go through it. So I'm not going to cover it here, but those are the breadcrumbs that you can pick up on if you're interested. You take the low-level API. That gives you the cache. You take the primitives that you get from React, you combine them together to write the high-level API, and that is what Daniel Baroff presented at JSConf and React Fest. And those are the new things that we're gonna play around with, and that's .future, by the way. And the source code's here. Anything in blue is a clickable link. So you have create fetcher, which creates the fetching mechanism that reads from cache. You have a few components, a placeholder and loading, which help you sort of coordinate logic. And then you have a defer set state, which helps you prioritize state setting. Don't worry about all that. We're going to go into it. But can you see how we're slowly building up to a cheat sheet of like this belongs here, this belongs there. So we've just gone through the rough code sections, and I think this is where people start to get really lost about talking about React Suspense. They jump between code and benefits and uses and goals and computer science terminology, and it's a whole mess. So I think if you keep this mental map in mind, you have a much better time understanding and communicating about what is it that you like or dislike about React Suspense. So let's keep going. Now we'll talk about benefits, use cases, what can we do with it, as well as the goals. What's the big idea? What's React's priorities? And I think I've through my reading and research, I think I've understood it somewhat. I'm sharing with you my thoughts. These are not the React team's official thoughts. So the big problem that we solve right off the bat is data fetching. If you ever play games, you'll notice sometimes that tearing is unacceptable. These screens are very small, you can't see it, but there's a line going through that Counter-Strike screen. That's called tearing in games. It's unacceptable to them. They hold themselves to very high standards of performance because they want every screen to immerse you in that world. So if tearing is unacceptable in games, why do we have tearing in our apps, right? So when we load apps, we often switch to pages without the full data there. Only when we land at the pages, then we pull the data. So that's the analogy that I'm trying to draw. Spinners equals tearing. So why do we show spinners by default, which is the question? Maybe there's an opportunity for a better default. That's, I think, the argument that the React team is implicitly making, and I'm making for them, I guess. So how do we implement better defaults? On the top, you're going to see how things are normally done in React. On the bottom, you're going to see my perception of how things could be done in React Suspense. On the top, so over here, we're data fetching, right? On the index page, we're going to click on the index page, and it goes to a movie page, for example. This is, if you've seen the React Suspense demo, that's exactly the example that we're going through. Only when we land on the movie page, we go to component did mount lifecycle method, then we call a fetch to the API, and then we get the movie details. In the meantime, we have a useless spinner. That's pretty useless. Can you see my mouse? I think you can. Okay, so that's that's the status code. The status code is to show spinners by default. But what if you could reorganize your display paradigm where you fetch, when you click, you fetch, but your old page continues to be interactive, and only when the fetch resolves, then you show the fully loaded page. So that's the new thing. It can be done with React Loadable, but now it's a primitive within React. So this is how simple the code is. Here you see our old friend create fetcher, and we're just using it within the render method. There is no lifecycle method here. It's used completely asynchronous. And Matthew, this is functional programming with side effects, which kind of throws people for a loop, until they and the main thing you have to realize here is render. The render cycle doesn't have to be pure. Pure means no side effects. It just has to be idempotent, which means every single time you call it, it gives you the same result. So that's a better way to fetch data. What about data? What about images, right? I can fetch images in the exact same way. When I click to travel to a movie page, the movie page then loads an image tag with a source tag. That source tag then fetches the image, and then it loads and it jumps, right? Like you see images jumping when you land on pages. I'll have an example for you in a minute. What if you could click on a page to navigate to a new page, and have the image fully loaded before you navigate to that new page? So that's a nice thing to have. Just to drive it home, this is how easy it is with the create fetcher API. Again, you wrap the image constructor in a promise, and then you just call it in your render. Same thing with CSS. No more flash of unstyled content. So these are all very, very basic synchronization problems that are solved for you. Let me just really drive home the fact, what happens when image loading fails you. This is the only GIF I have. I call it the Hawaiian Missile Alert Software Edition. You're a regular sort of React Hawaiian Missile Alert programmer, and you do this UI, and you have this, and people click on this, but then they click on the wrong button. And terrify a whole island of people. So this happens. Like, even though you don't have this specific situation, I know all of you have done this in your apps, where you have stuff that just loads after you land on the page. Why is that the default? Can we do better? And then you can also do data fetching for code splitting as well, which is very nice. So your chunks arrive and display nicely. So those are all the new things that we've talked about. Benefits, users, goals, and we use the code that we talked about over here. And I still have the poop. I'm still loading. So let's go on. There's so much to unpack in React Suspense. What about race conditions? We have better defaults in race conditions. In the old React paradigm, if I condense my fetching into the onClick method, right, and I click a few times on different things, they can resolve at different speeds. And depending on whichever resolves last, that's the one I see. instead of whatever I clicked last. So if I click on movie page 1 and then I click on movie page 2, but then movie page 1 just takes longer to return, that's actually the one I end up with. But what if it was entirely dependent on just like the click order, because it just remembers what I click in a fetch, it solves the fetch condition because it just disregards whatever I click for movie page 1. So that's what I have here. Again, I don't expect you to don't get lost in seeing the code. I realize the screen is too small for you to see it anyway. But again, this is all available online, and just get the big idea that we fix race conditions by just having a better default. It never shows the old, if a new movie is selected, it never shows the old one. So that's the first race condition I can identify in going through all the demo examples. Race condition 2, what if I am moving to a new page and the new page has 2 components inside it? So let's say from index page, I'm going to movie page. Movie page is made up of movie details and movie reviews. Let's say I go to movie page and movie reviews loads, but movie details hasn't loaded yet. Then I only see a page with a half-loaded thing. It's incomplete. And then I see the full rendered page. What if I change that paradigm to I load movie reviews in the background? You can see it's grayed out here. And then only when both things are loaded, then I show that thing. Then I show both of them together. In synchronous React, the default is the top one. In async React, this is all you need. It is by default, the rendering will wait for both things to be fully loaded before they show you. So it changes the default settings, right? I hope that really gets home to you. And remember Lodash? Yeah, no need for that. We have debounce. This is how you implement debounce now with the React.timeout primitive. You just wrap it in a delay function and you put that delay next to it because both of them have to load together to create a debounce. The source code is actually part of the React Suspense tests. And you can see how you can get ideas on how to use React Suspense by looking at the tests that they do for React Suspense, because that's how they expect you to use it. So again, some more functionality here. I know I'm going through a lot, but please take some time to think about, like, could you use this in your apps? Some of this will be completely useless to you. Some of this will be exactly what you've been looking for all this while. So those are the 2 new things. We fix race conditions and have a nice sort of free debouncing thing. And by default, we switch the default from everything is a race condition to everything is not a race condition by default. What if I want race conditions? I mean, like, you're not the boss of me. I want spinners. Like, give me my nice things. Sure. Like React always has. Thank you. React always has escape hatches, and that's part of the official design policy. So what if I want this? I want index page. I want to click, I want to move to movie page, show the movie details, and actually have a spinner. And then once the movie reviews load, then I show the whole page. This is what I want. React Suspense doesn't let me do this now because it waits until both are loaded, right? Wrong. So we have intentional states. So remember that placeholder component, you just wrap it. You just wrap placeholder. You go from this mode where you have both sort of side by side together. You wrap the one that you want in a spinner in a placeholder component, and React does that behavior for you. Isn't that nice? What about if I click on a page? So there was a hidden flaw in the paradigm I was outlining earlier. When I click on a page and the old page still remains interactive while stuff is loading in the background, it's going to look as though I didn't click anything. It's going to look as though the page is unresponsive. I want to show a spinner while I'm loading the page, and then when everything loads, I want to transition over. I want to show this spinner here, not over here. How do I do that? Got your back. It's the loading component that we also defined earlier. All that was in 30 lines of code. So it's very, very easy once you have the right primitives to compose these things which let you declare what you want. If you were to do this imperatively, you would have to do you have to put is loading in state, or maybe past delay, because there's the delay thing in your state as well. And then you have state explosion just from multiple things coming out at the same time. Whereas here, everything's sort of managed for you. So that's a very nice new thing, which is hard. This is one of the hardest presentations I've ever done, because these are very nuanced things that hopefully I'm communicating well. Intentional states as a use case. The goal is precise control, and again, you're using the same code to do all this, to accomplish all this. This is a bonus. I don't regard this as something that most people should do without thinking, which is cheating FastUI with preloading. So imagine if from the index page, you click the first movie, and you go to the first movie, and in the background, while the user is still looking at the first movie, you silently load the second page. So obviously that's doable in Angular and with React Loadable, but now you can just easily, and preloading preloading kind of looks like this. It looks so much faster because as you load the page, you kind of load the next thing because you're just guessing what you're going to want, and things just like load alongside. With React Suspense, this becomes very easy. It's just declarative. You can guess the file names of images that you might want to load, or you can guess the n+1 query of stuff that you might want to that your user is likely to click next to, and obviously it's going to load instantly for them because you're using their data. Don't tell them. So that's preloading, that's the use case. The goal is speculative fetching or speculative rendering as well. We're going to get into that. That's going to be the hardest part of this talk, I promise. And the last sort of goal of React, and this is a big assertion from me. I haven't checked this with anyone, but like this is what I've arrived at, which is React wants to be interactive and fresh. AKA, React is probably more or less changing its name to Interact, or AKA React has a new job, which is stay interactive at all costs. So for example, 60 frames per second if you're talking about web. But remember, this is React. You're not just talking about web. AKA why Suspense belongs in React. So some of the more nitpicky engineers among you might be going like, why do you have to? Why does this belong in React? Why do we have to rewrite React? Why can't I do a whole higher order component to contain this throwing and catching behavior? And that's the hardest part to understand. Before I explain that, I have to explain misconceptions. A lot of us have been trained with the idea that committing to the DOM is expensive and manipulating a virtual DOM is cheap. That is wrong. The new focus is actually that committing to the DOM is cheap and reconciliation of the render tree is expensive. How do I show that? I prove it to you with these diagrams from Andrew Clark, where in synchronous mode, this is how long it takes to render your React tree, and this is how long and in the pink line is how long it takes to commit to the DOM, the actual browser DOM. In async mode, we're able to time slice and chop things up so that we can start being responsive to browser events, even though we're still rendering the tree. It's not hypothetical. We have actual demos out here you can go and have a look at. Again, everything blue is clickable. So this is an implementation of React Fiber and showing that you can split things up into nice little chunks. Dan also used a Git analogy. He kind of skims over it in 2 slides. I think that is like the core. If you want to really understand this stuff, you do not, by the way, you do not. This is like really high performance stuff. So imagine if we're an emoji app and you were working with continuous deployment, and your emoji app and continuous deployment is way over-engineered. It pushes from development to production every 16 milliseconds, no matter what you have in development. Imagine if you did not have Git. This is what you do, right? You're happy, and then something happens, and you're doing work, and you're committing to deployment. But because you're doing work, the stuff drops because you can only have 1 unit of work. JavaScript is single-threaded. Then you realize, oh, I need this piece of data. I don't have this piece of data. All right, but the browser really wants it, so I'm just going to push it to the browser, push my half-complete work to the browser. Then I get another user interaction. Then I get my data, and then only when I get my data, I reconcile everything, and I have my finalized work, and then I push it out. So this is dropping frames, and this is showing work in process state. Not good. So what if we had Git, right? Like we all use Git. Git is great. Git is good. So just that invention of forking things and working stuff in production, and only after and keeping production happy while doing things in work in process, and only after you're done rebasing everything to bring the production pushes up to speed with all the work that you've done. Only when you're happy with all the stuff that's going on. The only way that this is possible is with 2 different branches, right? Like we all know this. This is how Git works. So that's an analogy for what's going on with, pardon this chart, what's going on with React and React's reconciler. This is a DOM. I want to get my octopuses right every 16 milliseconds. I want to commit from every tree, from the tree, and then I suspend when I have a user action, and it fetches data. And then I rebase when that fetch is complete, and I commit the final result at the end. So a couple terms I want to introduce to you here very briefly. This technique is called double buffering, and that's a technique that's taken from game development. It's also called coroutines. The idea that even though JavaScript is single-threaded, we're operating and hopping between threads as though we're juggling balls, like we're doing two things at once. So it's not as though we're double-threaded, but it's kind of like it is. So the React team kind of actually takes this Git metaphor very seriously. They actually call it committing. They actually call it rebasing. So these are real terms as much as I could understand them, and hopefully that helps you understand that React is really rendering things in the background. Right? That's as far as you need to know for React Suspense. For time slicing, this high performance stuff really matters more, but React Suspense only cares about this stuff in the background. Capiche? So the only thing I've added is the goal of React being interactive and fresh. And I want to impress upon you, like, if this was not a goal, React would not have to have been rewritten. We would just have to publish a separate library. Because this is a goal, because this is so important to React, they rewrote the library to incorporate it as part of the base behavior. I think that React Suspense is going to usher in a period of a lot of innovation. I'm sure some of you were pretty surprised by this use cases of data fetching. Like, I can fetch CSS with data fetching. I can fetch images. What else can I fetch? So those are very interesting things, and don't limit yourself to just the web. What about React Native? What about React hardware? What about React, TV? Low-level APIs, all done in user land. This is going to be all in open source. So everyone's going to want to come up with different ways to solve this. High-level APIs, is this the right way to do things? The future implementation is just the first one. Brian Florence has already come out with what he thinks is an interesting way to approach the high-level APIs. So check out reactions/fetch. And then what are the impacts on existing React libraries? Like, what does it do to React Router? What does it do to React? Well, we know that React Loadable is basically dead. What does it do to React for animation? What does it do for React Native? And then we also need new dev tools, because we've never had these concerns before, because React has a new job, which is rendering things in the background. So these are all the things that, and I don't even know what else might be happening. So these are all the potential things that might be coming in the future for React, just based off of this fundamental rewrite. These are some other stuff that we don't have time for, but I encourage you to have a look at. And that's the complete cheat sheet that we arrived at after all this work. And now that I have my octopus back, I can go back to my main presentation and show you the completed cheat sheet, which is great. I've also marked it up with stars, so everything with 1 star is, I think you should pay attention to, because I think you're going to use it probably daily. Everything with multiple stars, 3 stars, 4 stars, whatever, probably opportunities where there's going to be a lot of innovation, and you might want to take part in that as well. So I want to end off with, what does React, I started off with, what does React let you do without thinking? And now I want to ask, what does React Suspense let you do without thinking? It's a lot, and we don't even know the half of it. Like, it just has started right now. I also want to close off with the final quote, which is about the pit of success. When we think about API design, we want everyone to have good defaults so that they fall into winning practices, and make it easy for people to do the right things, and annoying, but with escape hatches to do the wrong things. So I highly encourage you to read up on that chat. And that's what the React team is working so hard to do for all of us, which is continually think about, re-examine what is the job of React, what can we do better, what should we handle, and what should the user people handle. I want to acknowledge these people and links. You should definitely check out all of them. That's what I went through in terms of piecing all this together. And thank you very much.